Hey guys, it's Rez. In this video, we're going to talk about how the computer kind of works. And this is going to enable us to understand better how to program. A lot of times I notice people don't really understand what they're doing, they just copy paste. And I think having a general knowledge of what's going on in the hood is kind of gonna make more sense as you go along. Why are we doing this? Why are we doing that? And again, I'm gonna broaden this knowledge. So basically, I'm gonna be somewhat vague sometimes and whatnot. We're not gonna spend hours on this. And you'll notice some stuff I say now, I might contradict in a future video. Why? Because it's easier to understand some stuff partially at first, or a bit differently, because it'll make more sense, right? The more common it is to our knowledge, it'll be easier. So with that in mind, remember to take everything with a grain of salt, and always do your own research to make sure that it's correct or not. But hopefully you trust me, or at least I hope so. Anyway, so to get started, what I would like to make you understand is how a computer kind of works. Okay, so inside your computer, you have a bunch of things that you could think of. I usually would ask my students to give me some stuff in there. But you could think of, there's like the power. Let me see if I could, right there. There we go. So the power here. Sorry, it's not the best writing thing on my computer. So we have the power. Actually, let me clean it up a bit. Later on, I'll make videos with items and whatnot. Just I don't have time. So we have the power in the computer. This gives it energy. You could think of it as a human eats food and whatnot, and this gives them energy for the cell. This goes still for the computer. Now inside the computer, it also has this thing we would call a brain. In this case, we would call it a CPU. Inside the CPU, this is where it will make decisions to go left, to go right. So this is basically the brain. Right? So this is where it would make the decision of going left, right, sideways, to pick the color red over blue, etc., etc., all those stuff. And we have other parts in there. So we have something like a short-term memory. In this case, it would be something like a cache. And we have the long-term memory, which would be, data. So this is our storage, basically. And there's a lot of other stuff, but we're not going to talk about it. But what we notice here, we have power, we have CPU, we have cache, and we have data. And we wonder, how does it decide things? How does it do anything? Well, in this case, it would be about sending signals. So the power gives it this electricity, a current. And this current is going everywhere, from here, CPU, to cache, to data. It power sends it wherever it wants, and they all communicate to each other. Wow, my lines are horrible too. And the point is, with electricity, we could pass information as well. I'll give you a little example is, computer right now, most of you should already have heard of this or something. It's actually all little ones and zeros, right? This is something we call bits. These ones and zeros are actually built on the foundation that, again, I am bringing this down. So anyway, so ones would be there is current, and zero would be no current. Right? So now that the power is coming in, if we control it, depending on how we send it, we have power and we don't have power, we could send some sort of information. This is actually how it works when you're playing games or when you're getting something from the phone and whatnot. It's sending a lot of ones and zeros, but at little intervals of milliseconds or microseconds or whatever you want to say. So based off multiple of this, we could indicate something. We're going to come back to this in a second. So now, knowing that with the power we could send information, which is either there is power, let's say as an example, if there's power it's a 1, if there's no power it's a 0. This actually changed over time, but that's the initial thought. Now they found a way to also say, hey, you know, when you pass through here, if you want to store that data, let's say that information, electricity can't live forever, we could kind of turn this on and turn this off. So depending if it allows power to go through or not, it's a 1 or a 0. And the thing is, there's a lot of these little guys inside our cache and inside our data, even more inside the data. Hundreds of thousands of millions of these little dots together where they could store electricity. And again, there's a lot of information missing here. I'm just making it as simple as possible. Now, what they decided is they said, hey, we could take a section of this and make that for, let's say, letters. We took another section for numbers. We took another set of this thing inside the data again, a bunch of these little bits, a bunch of these little places where we could store electricity or not, and we said this is, you know, my Chrome, and so forth, so on. So inside the memory, we have a lot of these places that we could store values, right? And inside the cache, it's temporary. Inside the storage, it's permanent. Well, again, this is for another day of some sort. But the fact is, we could have a lot of these 1s and 0s, and we could save them. And now, because, well, actually, we'll come back to this in a second. Let's actually bring this. Let's go here. So now that we said that 1s and 0s are actually stored inside our storage and so forth, so on, and we had to group them. Why do we have to group them? What does it mean? Well, 1s and 0s, right? 1s and 0s don't mean much to us. Actually, let me go to a new one. 1s and 0s don't mean much to us. It's basically, and having two screens doesn't work with this thing. So 1s and 0s don't mean much to us. It's basically there is current and there is not, right? So how would this make any sense to us? Well, it doesn't. What happens is we group a lot of these 1s and 0s together, and the sequence of these 1s and 0s together is what gives us information. So 1s and 0s by itself is not good enough. But if you add in, where's my mouse? There we go. If you add in, let's say, a lot of these zeros, we can make that equal to 0. Now let's say out of these 8, there's 8 bits, right? Again, a bit could only be 1 or 0, and there's 8 of them together. This would equal 0. If I wanted to have 1 as the value, well, I'll turn on the first one, have electricity in there, and the rest I'm going to set them to 0. Right? Now, if I wanted to have the value 2, well, again, I'm creating a sequence that I determined beforehand, whoever made the computers, whatever. They could have made this to any type of sequence, but they made it an easy sequence. So if I add a 1 here, well, electricity could only contain 1 or 0, so this becomes 2. You can't have 2, so the 1 goes here, and this becomes 0. Just like normal math when you're going from 9 to 10. So this becomes 0, and the rest is, right, 2. 3 would be the same thing, add another 1. 4 would be, again, you add, it adds, and it becomes here. And you keep on going, right? So now, based on how much electricity you stored, you could determine what value it has, 1, 0s, and etc. So this is what a sequence means. And again, you could do the same thing. You could do the same thing you did here for 0, 1, 2, 3, 4 for the letters A, B, C, D, A, H, G. Right? You just say this part of the memory is for that. A, B, C. Sorry for my handwriting. D, E. This is going to be the worst experience you're going to have with this, but then afterwards I'll clean this up in the future. It's just I'm in time constraint. And again, it didn't need to be in the same values, but you create a sequence that determines this is 1 0, etc. And they did this for everything, for numerical values to etc. So the goal of doing all of this was to bring something that was, to bring something that was zeros and ones, a computer language, basically a computer language, to something more understandable, which would be, oops, a human language. Sorry again for my handwriting. 2 screens making my board really messy. Anyway, so they're trying to bring a computer language into a human language. So basically from zeros and ones to go into an English statement where it says, go over there and fetch me Coke, basically, or whatever it is. Go write to me or draw to me or have a better handwriting eventually. So we're trying to make those zeros and ones into that. So to get there, we make sequences. So the first sequences of these equals characters, etc. And as you go up, you get something such as hex codes, and as you go up, you get to languages now, where it's a bit more English, like C++, C, etc. As you go further up the line, the further it becomes into a human language, the more readable it becomes, but also the more limitations we add in. Why I mean by limitations? Well, at the computer language, you could put any sequence of zeros and ones, and you already determine what it does. You could make the machine do pretty much anything. But this is so complicated. You'll need billions of these zeros and ones, how to remember it, and worst of all is how to read it. It becomes painful. It becomes way too painful. It's not possible. You would just hate yourself. So we keep on going up in the levels, but that also means if we don't have something that translates back, it doesn't work. So this is why the further we go up, the further we create limitations on ourselves, on what we could do with the computer. And again, over the years, more stuff is getting translated, becoming better, faster, etc. But this will take always time. So the further up the language you are, so let's say a lot of people are going with Python and they're like, hey, I could do pretty much anything. Yeah, of course you could do anything, but you could also do it with Java and C++. And they're like, well, yeah, I could do that too, but it takes me 1 line of code, while over here it takes me 5, over here it takes me 10, over here it takes me 100. Yeah, again, you do that, but in the end, for your code to run, this is what's important, you got to remember, is it actually needs to get compiled into something that the computer understands. So to compile something, you have to go back down. So when you compile your code, it's going to translate back those English statements into something that's more computer readable, such as zeros and ones, right? And again, because we created this thing where we're trying to reach human language and we're going backwards, there's going to be a lot of stuff that's not translatable. I can't tell the computer, hey, go to my house and fetch me my favorite beer. Well, it doesn't know what my favorite beer is. It doesn't know where I live. It doesn't know how to drive. It doesn't know how to get anywhere, right? It could only do what it knows how to do, okay? So something I like to say to all my students, and you're gonna always forget this because you came in the world with this technology that's blooming and we all think it's AI is gonna become the next thing that's gonna conquer the world. It's actually computers are really stupid. Really stupid. You wouldn't even understand how stupid they are. And we believe that they're not, and it's actually they are. They just do the instructions we said. So the instructions is what matters. So instructions, wow, I really can't type here. Actually cancel that. So instructions that we give to the computer is what matters. Now, how correct your instructions are, the better the computer will do what you asked it for it to do. The computer is not smart enough to know left or right. So if you tell it to go into a wall, it will go into a wall, right? So computers are really stupid. You got to make sure that your program is flawless. It works. There's no possibility of mistakes, etc. This is what we're going to try to do. So in the end, always remember that a computer is stupid, and that you shouldn't assume that the computer is going to fix your mistakes, because it doesn't know. It doesn't even know what you're trying to do, right? Sometimes some people are going left and you want it to go right. Well, the computer wouldn't know that. Well, you're going down the street and the sign says one way, and then the computer went on the opposite way. Well, of course, the computer doesn't know. Unless it's been programmed to, unless it's been told and foretold that this is the rule, this is what you should do when you see this, it doesn't know better. And this is a big mistake I see a lot of my students do. Okay? So hopefully you understand that, and hold on to the bits we're talking about, how the memory is stored. Because we're going to come back to that when we're creating our variable in the next video. See you guys then.